but I'll need a textbook for this one, which is page. Basically, we're just finishing up page chapter 2. So it means from the next week going up, we're doing assignment 3.
Yes.
Yeah. Okay. Now that we have some idea of the domain, I think now we can move very quicker. I think today's session was that a lot of people didn't go through the previous work. That's why it was a bit of a problem, you see. So stop recording. Oh, it was recording already. Okay, sorry, my bad. Word document. Yeah. So now we're going to look at the combinations of functions. So we are combining functions, basically. This is where you look at the other part of the assignment. That's why I want you to look at homework. I said homework. Now I want 12 submission and more. Homework, I said question 1.5, question 3, question 5, question 6, question 7, question 8, question 9. You submitted by Monday after doing this session. So as I said, it's not compulsory, but if I get 12 submissions, we get a discussion class. If I get double the submission, 24 submissions, it means that we get 2 discussion classes. It's up to you. So now this will be on page 210. It says combining of functions. Let me start here. They say, let's say we have a function f, né? And this function f has a domain. Remember we said, I don't know why I like GG. Yeah. Okay. We say that the domain, sorry about that. We say the domain of f, let's say, is equals to a, right?
Ma'am,
Yes.
like, is it me or I'm not seeing a screen?
Yes, I'm also not.
Did you share your screen, ma'am?
I'm trying to check that, and I didn't. I'm sorry about that. I was talking to myself. So now, let's say, okay, let's start afresh. Let me breathe. Yeah. It's too much drum. So here we'll be looking at combining functions. So the reason why I started with domains back then is because I wanted us I wanted that to help us understand finding the domain of combining functions. Right? Oh, yes. So now let's say you have a function f. You can see that right now.
Yes.
Hello? Thank you.
Yes, ma'am.
And then the domain of f, remember we said f will represent our domain in this case. Let's say the domain of f is A. And we have G, the domain of G is B, right? Now, if we do the following combinations, f plus G, right? It means that we're taking the function of f and adding the function of G. Then the domain of f plus G will be the intersection of the domain of f and the domain of G. Are we all together there? Yes, no?
Yes, ma'am. Yes.
Yes,
Good.
ma'am.
Now, I want you to see this. Guys, remember your exam is multiple choice. So I can say, before that, let me continue. If you have f minus g, the domain of f minus g is also equals to the intersection of the domain of f and g. Are we all together still?
Yebo. Yes,
Yes.
ma'am.
Have
Yes,
f
ma'am.
times g, the domain of f times g is equals to the domain of f intersects the domain of g. We're all together, right? I want you to remember these when we do the example.
Yes.
Now, if we have f over g, that's what we did have last time. You can put some x here and do x there and x there and x here. Then the domain of f over g is equals to the set where x is an element of the intersection of the domain of f, please mute, and g, such that g of x is not equal to 0. So you need to remember this table, which is the algebra of functions. And that is on page 210. Are we all okay up to that point?
Yes, ma'am. Understandable.
Thank you. Now, so we will move now. You see, now we are moving. So let's look at the example that we already have in our textbook. They say f of x is equals to 1 over x minus 2. Now, g of x is equals to square root of x. So we know that, remember, the first part is, okay, before I go there, they want us for A, they want us to find f plus g and its domain, f minus g and its domain, and f times g, its domain, and f over g and its domain, and their domain. Are we all clear on what we are supposed to do? So,
Yes, ma'am.
thank you. Let's look at f plus g. We know that our f plus g is 1 over x minus 2 plus square root of x. Because they want us to find f plus g, we're just adding the two functions. So what will be the domain of f plus g? Anyone?
2 must not equal, x must not equal to 2.
Okay. Is that the only one?
No.
No. Good afternoon. X
Yes.
cannot be negative.
So it's x such that x is not equals to 2 and x should be greater or equals to 0. That's what we are saying.
Yes.
Yes, that is what I'm saying.
How did we get that?
By combining two
sorry.
domains.
Before that, one person, please.
We can talk some people.
I'm giving you a chance. You can speak. It's no problem.
Guys, you have a lot of chances to speak. Your exam is in October or September, there at the end. So anyone who speaks, I'll still want someone to speak. So let's speak. How did we get there?
Like when we combine two domains, I think you take the domain of f of t, domain of, and the domain of g, f of nt, the domain of f and g, and then you.
How did you combine them? Union, intersection.
I think is union. Not sure.
Remember what I said. If you have f plus g, then the domain,
ma'am.
yes, of f and g is the intersection. So that is, what did I say? Domain of f and domain of g. So how did we get here? right? We said that our f of x is equals to 1 over x minus 2, and our g of x is equals to square root of x, isn't it? So we know that the domain of f is x such that x is not equals to 2. And the domain of g is what? X, element of real numbers such that x is greater or equal to 0. Now, when taking the intersection of that, right, it means that the domain of f plus g is equals to x such that x is not, is greater or equals to 0 and x is not equals to 2. Are we still okay there?
Yes.
Or should I go down? Now remember what were we using in the previous session? We talked about it a lot. What did we use?
Interval notation.
Yes, interval notation. What else did we use to find that interval notation?
Number line.
Thank you. So before we get here, right, I want you to look at this domain and I want you to look at this domain. So you draw your number line. Are you now sorted? Those who attended the previous session, are you sorted with the number line? How we were doing it?
Yes, ma'am.
Good. So I'll need help here. So let's draw the domain of, let's start with the domain of x not equals to 2, the domain of f. So we go here, we put a 2 here. Would it be a closed circle or open circle? Guys?
Open circle.
Open one.
Thank you. It will be an open circuit because we're not including 2, right? So this domain, what does it mean? It means that x, okay, let me choose this one. It means that this function f is defined for any value of x to the right of what? To the right of 2 and to the left of 2, but not including 2. Are we all sorted there?
Yes.
Yeah.
3 yeses?
Okay, ma'am. Yes, ma'am.
Thank you. Now, let's draw the other domain, which is the domain of G. Isn't that we say this is the domain of F? Now let's draw the domain of G. The domain of G says I go to 0 and include 0. It means I draw a solid line here, right? And I put 0. Where is it? Where does it say I'm going? Where am I going? X greater or equals to 0?
Positive infinity. Yeah.
Thank you. To positive infinity.
Yeah.
Can you see my orange line on top of my red line?
Yeah.
Yes, ma'am.
Yes, ma'am.
What are the 2 lines doing? They are intersecting, they are touching, isn't it? Do you see that? It means where the 2 lines are touching are common values. So the red line is on 1, the orange line is also on 1. The red line is on 2, the orange line is also not on 2, sorry. The red line, if the red line is on 3, here, the orange line is also on 3. If the red line is on 4 here, the orange line is also what? On 4. So when they say the intersection, you look at the values where those 2 lines are touching. That's your domain. Do you see that? Yes, no?
Yes, ma'am.
Another yes or
Yes.
no? Good. So it means that the set notation, this one that we wrote here, plus G is equals to X such that X is greater than 0. We can see from this one, it's 0, and then it goes further and further and further and further and further So x is greater or equals to 0. And x should not be equals to 2. Why is x not equals to 2? If you check inside the purple circle, is the orange line on top of the yellow line?
No.
Thank you. So x is not equals to 2. So let's go to interval notation. Can someone help me by looking at that number line? What will be the domain of f plus g in interval notation?
Yeah. Can I try?
Yes, please.
From negative infinity. Close bracket.
Close bracket, what? Square bracket or round bracket?
Close bracket, square bracket,
Square bracket. Okay, I'm having an eraser here, sorry. Okay, square bracket.
0 to infinity.
Yes. To infinity.
Yeah. And
Another
union.
try. Okay, sorry. Union.
Zero. I'm not sure about this one, but
You see
0.
that you made a mistake.
Yeah.
Look at it and then tell me. Again, look at the number line, and I want you to write using the interval. Where does the orange line on top of the red line? Or guys, you don't see that? Maybe I should use a green, a different color. Hmm?
No, ma'am, it's visible. But
No, we see.
you see, it's
So
visible.
give me where they intersect. Where do they intersect? Where do they intersect?
Ma'am, can I give it a try?
Yes, please.
Square bracket.
Yes.
0.
Mm-hmm.
Then 2 and a bracket.
What bracket?
The
Square or second?
Circle bracket.
Why?
Because that's where they intersect. The intersection is from 0 to the 2, and the 2 is not included.
You see, inside the circle, there's no red line. Do you see that?
Yes.
Only orange line passes through. That's why we have this bracket type of bracket and not a square bracket. Yes?
Yes.
Only this one.
Let me
continue, which means union on top
Yes.
of, and from the sun.
No, you're right.
So do I need to include negative infinity, because at rate it does pass to the 0. So which means will be negative infinity to positive infinity. And let's go open bracket. Let's say open bracket.
Open bracket.
Negative infinity.
You're contradicting the first answer once you introduce negative infinity.
Ish. Okay, I can cancel it, man. I see.
Someone else?
I think is open bracket 0. Open bracket 0, comma
0, comma
negative. I'm sorry. Let me see. Positive infinity. Let me see. Union and 0 plus and goes there as negative infinity.
Guys,
Consider the red line.
Listen to this. The interval notation that you need to focus here is You're asking yourself, where are the two lines touching each other? You look at the graph and you say, where are the two lines touching each other? The red line and the, okay, maybe let me do the red. Let me change the red line to be blue. Maybe. So let's say our new red line is blue. So we're saying the intersection. Where is the orange line touching the blue line?
From 0.
Two way. Now, Gesizu. Wait, I don't know if I'm going to with African languages.
I think it's from
Lama line amabili. Mo go tlhakanang teng di-line tse pedi. So if you can find that interval, then you're out of dumb. It's just you're not giving me the right answer. I want the right. There's no one who's dumb. I just want the right answer.
It's
so where
positive
is
infinity.
the Tagani?
From zero passes through the circle to the right, which means is zero and comma positive infinity.
Sorry about that. You are right, but we need to write it mathematically. So
okay, let me talk, man.
Yes, try.
Okay, talk.
Mathematically, square bracket.
Square bracket.
0, 2, close brackets that curve 1.
Curve 1. Yes. So waiting.
And intersect.
Not intersection.
Union.
Union.
Oh,
yes.
Union.
Yes.
0 included.
Why are you including 0 now?
Union. Open brackets.
Get it right. Open bracket.
Yeah, I got the man.
Guys.
Yes.
Remember, you are moving like this. You are moving from left to right. You said, okay, it's here from 0. Because 0 is solid, you including, that's correct. You include 0, that's correct. So these two lines, they touch up to 2. The 2 is an open bracket, open circle, it's not included. That's why this bracket is like this. So these two are correct. Or they also intersect where. So this is also correct. Where do they intersect as well?
At 3.
From?
3.
Infinite.
From where to? To infinite. Yes.
Yes.
Are you sorted now?
Yes.
Guys. Okay. So you go to the, that's why I'm saying that. You look at your number line. Sorry?
Can I please, why don't you include 2 on the second interval?
It's because, remember we're saying the intersection of the two graphs. When I drew the orange graph, do you see the orange graph?
Yes.
It passes through the second for 2, and 2 was not included. So if a number is not included, we use an empty second. You see that? So
yes.
It means that the blue line it moved from here to here, and then it jumped 2 and moved from there to there. That's what it did.
Oh.
Hello, Mr.
So we're not including 2 because it's not included. And you see here, it also starts from the number 2 upwards. So here we are including numbers such as 2,0000001.
Oh, and
We are saying starting from 2 to infinity. So that's why we're saying, okay, our graph, our line, our two domains, they intersect between 0 and 2, or they also intersect after 2 to infinity.
Oh, yes.
Now we are sorted, right?
Yes. Why do you use the union sign? Why not intersection?
Because you're not saying they cut here and here. Look at this. You're saying that my two graphs, they intersect at 0. So it means that my function is defined here, or is defined here. That's why you're using the or. Yes, my function, this function, f plus g, is defined here, or is also defined on this interval there.
Oh, thank you, ma'am. I understand now.
Good. You see, now that you understand, let's do the next one. So we have f of x equals to 1 minus x minus 2. Then g of x is equals to square root of x. So they want you to find f minus g. That one we know is 1 over x minus 2 minus square root of x, right? So they want you guys to find the domain of f minus g. What is the domain of f minus g?
X must not
element of real number such that
x must not equals 2.
So let's do x must not equals to 2 and
x greater or equals to 0.
Why? Because you got it very fast. Why? Why did you do this? Why didn't it take you time?
I think because the one.
Wait,
okay.
Wait, let me answer first and then you'll answer the following one. Because
what was the question again, ma'am?
My question is, why didn't it take you time? Like question 1, f plus g, f of x plus g of x, we took time. Why are you giving me the right answer like that?
Because I can see them, and because because I
see them.
The domain is always the denominator. If we have a fraction, and then if it's a square root x, the x is always greater than equals to 0.
You are right. Okay. The person who wanted to answer after, can you please answer? Because he's missing something that I want to hear. What did I say?
For me, I think that before you have mentioned that f minus g, the domain of f minus g is the same of the domain of f plus g. And the previous question you just mentioned the same. So the answers we've got from f plus g, the domain of f plus g will be the same for the equation of f minus g.
Does that make sense now? Guys, 100%.
Yes,
do you hear that one?
Yes.
Thank you.
Yes.
Give me, okay, I need a new page for this one. So we have f of x still is equals to 1 minus x minus 2 minus square root of x. Therefore, what am I saying? So this is g of x, sorry. I'm just tired. F of x times g of x. Give me the domain of f of x times g of x. We know f of x times g of x. It means you are taking f of x, you're multiplying by them together. You're multiplying these two functions together. Please give me the domain.
This one I don't know.
X is greater or equals to 0. And x is not equals to 2.
How did you get it?
It's the same. When you multiply the domain of f and g, it's a intersection. So it's the same as when you minus f from g, or when you add f and g.
So you guys are you know the work. This is good.
No, we don't. We guess.
But now you understand after guessing, right? And I tell you it's wrong, right? So then you understand.
So, I will be wrong if I can take x and multiply by 1, because and then just say x must not equals to 2. I'll be wrong. Like that.
No, you will not be wrong. You're just simplifying what you're supposed to do, basically.
Oh.
But still, the domain is this one. As he said, the domain of f of x times g of x is the same as the domain of f of x plus g of x is the same as the domain of f of x minus g of x, which is the notes that I given in your textbook.
Okay, man.
Yes. So now, I want you to tell me this one. So they're saying that, yeah, this time we are moved. X minus 2 and g of x is equals to square root of x. They want me to find f of x over g of x. So I'm sure you can do that. So that is 1 over x minus 2 over square root of x. So this you can simplify it and say 1 over x minus 2 times 1 over root of x, which is equals to 1 over root of x, then x minus 2. Give me the domain. So the domain of f over g. X is such that
X.
Okay,
wait.
talk.
X cannot be equals to 0.
Okay.
And then x cannot equals to 2.
Someone?
Oh, you want another one?
Oh,
remember,
I always want 2 answers.
Okay, x, element x, x must be greater than 0. And x must not equals 2.
0.
Error.
So there are 2 answers here.
Sorry, I need to add equals to 0. No, I leave it like that, ma'am. It's right.
Why? Why are you saying I should leave it like that? It's right. Why are you not including 0?
If x is 0, it will affect the x minus 2. That's why it's simple to say x must be greater than 0.
Would it affect x minus 2?
Yes.
Not x minus 2. It will affect what?
Square root.
It will affect the denominator.
Yes, it will affect the denominator, because the square root of 0 this part will be 0 here. Oh, I removed it. The square root will be 0. So once the square root is 0, then this whole denominator will be 0. So this is the correct one. This one over here. Can I explain it why?
Yes, ma'am.
Yes.
Yes, ma'am.
Thank you. So the reason why, let me do this. Guys, it's important if you don't understand though, even sometimes when I'm preparing, I go back to the notes. D of f over g. remember they said it will be X element of the domain of F intersection the domain of what? Of G, such that G of X is not equals to 0. Meaning that all the values of X, that's such that when you substitute in the domain, will not what? Okay, so this part means that all values of X such that when you substitute it in G will give you 0, should not be included. Does it make sense what I'm saying, guys?
Okay, yeah, yes, it does make sense.
Yes.
Does make
So
sense.
remember here, like this part over here, let me choose a different color. This is what we have been dealing with all along, isn't it?
Yes, ma'am.
The intersection of the domain of F and the domain of G, right?
Yes.
We said that is equals to X is greater or equals to 0 and X is not equals to 2. Isn't that what we were saying all along? From F plus G, F minus G, and F times G, right?
Yes, ma'am.
Yeah.
But what value in here, in the domain of ours here, what value, so that when I take it and I substitute in G, it will give me 0. What is G of X? G of X is this. What value is in this set, right? Such that when I substitute, it will give me 0. G of X will be 0. What value is that?
0.
0. So meaning that they say G of 0 gives me what? Square root of 0. It gives me 0. So they say that take the intersection the way you were taking it of F plus G, F minus G, F times G, but remove every value that makes the function G, because it's the denominator, that makes the function G equals to 0. In this case, our X equals to 0 is the one that makes our what? Our function, what's this? Our denominator, this function F of G to be equals to 0. And in that case, we come to the one that we already have and remove the 0. So that's where we remove the equals to 0 and X becomes X greater than 0 and X not equals to 0. Does that make sense?
Yes, ma'am, it does.
Okay. Are we all sorted with combining that function, right?
Yes, ma'am.
So it means we can do the what's this, the assignment.
Yeah.
And then the
Yes.
interval notation, please go and try them again. I want you to, this is a set notation. I want you to also get used to doing the interval notation. Okay.
Okay.
Now there's what we call composite functions, right? This is a new session. Do you want a minute to absorb what you have learned? Or you are okay?
Yeah,
We are okay. You can carry on.
Thank you. Now we're going to look at the composite function. In this case, it's on page 212, right? What are the composite functions? So composite function
Page what, ma'am?
of, yeah, you say?
The page number.
It's page 12. I mean 212. The composite function. So when you're dealing with composite function, you're just taking a function and then you're putting it inside another function, right? So, for example, we write like this. That's small 0 and G of X. So we're just saying that, oh, sorry. We're just saying that we're going to take, isn't that when, okay, before that, this is called the composite function, right? Or also called the composition of F and G. So what do they mean? Remember you have F of X, right? And then you have a function G of X. So they're just saying where you see X in F of X, put G of X. So it becomes something like this. Do you see that?
Okay, ma'am.
Okay,
Okay, ma'am. Yes, ma'am.
Yes, ma'am.
I want you to listen and listen carefully.
Okay.
This here is an inside function. G of X, a function that is inside another function, right?
Yes.
Now listen. When you're finding the domain of a composite function, the domain of the composite function will be the intersection of the inner function and the expression of the composite and the restrictions on the okay, let me put it like this. The domain of a composite function is always the intersection of the inner function, the domain of the inner function, and the domain of the expression of the composite function. Can someone repeat what I just said?
The domain of the composite function is the domain of the inner function and the domain of the expression of the whole function.
Okay, let me see if I just wanted to clarify. Guys, one trick that works for me is if I can't, you take the statement and then put it in your own language and see if it makes sense. Sometimes if I don't understand the work, it's very important that you understand your theory, like these words that are in the textbook. It really helps. So if you don't understand it, you put it in your own language and see if it makes sense. Let me try Zulu. It domain, I don't know, there's no other way for domain. It domain, your composite function, right? Are we all together?
Yes, ma'am.
We told
Yes,
us
yes,
from
yes, yes.
the intersection of its domain, ye function yangaphakathi, kanye ne-domain ye expression ye composite function. Does it make sense? I wanted to remain in you.
Please repeat it again.
Okay. Kinali composite function and get it, right? Give it a composition here F G, right? Domain sometimes by wala so. Yeah. One side composition here F G. Now domain yeah F G, right? The intersection yeah domain yeah function ya ka mohara. Ne?
Okay.
Lead domain yeah expression. So if utoti, let's say 1 over x, the domain yeah expression yeah composite function.
Okay.
Lankushisha.
Yes, ma'am.
Thank
Yes,
you.
ma'am.
Thank you.
Loud and
So
clear.
we're saying that the domain for those who are not Venex speaking, we're saying that the domain of, if you want to find the domain of the composite function, right? It will always be the domain of the inner function, the intersection of the domain of the inner function, as well as the expression, the domain of the expression of the composite function, the domain of the expression of the composite function. Then let's say let's call this domain D of H. So that will be D of H. So should we go to the example now?
Yes, ma'am.
Yes, ma'am.
So here we'll need a number line. So let's say we have f of x is equals to square root of x. Guys, I'm hearing my echo. Thank you. 2 minus. Let's say we have that. All right? A. And they want us to find their domains as well. We have F composite G. This means that inside, guys, from right to left, the second one after the small second is the inside function. So meaning this is G of X, right? So where we see x in where we see x in f, we put g of x. So then this, so this is f, guys. My handwriting. So 2 minus square root of 2 minus x. I don't know what's going on. Okay, that's right properly. So this will be, we'll put g of x, this g, that's all. So it's square root of 2 minus x. So now, where we see x inside f, we put this whole thing. So let's do that. It's square root of where we see x. This is x, so we put that whole thing square root of 2 minus x. So then this becomes fourth root of 2 minus x. Are we all fine with the composite function now?
Ma'am, please explain what you just...
Okay.
Can
you explain from that square root into square root of 2 minus x? I didn't get that.
Okay. But okay, let me do this. Isn't that we are taking g, we are putting inside f of x, isn't it?
Yes. Yes,
right?
Yes, ma'am.
It means we end up here. That's what we are saying. We're saying we take f, we put what?
G of x.
G of x. Right?
Yes,
remember our f was f of x.
It's root of x, yes.
Yes. So now here it says where I see x, I don't put x anymore. I put what? I put square root of what? Of 2 minus x. So I go to f, this is my f. Where I see x, I see x here. I'll put square root of 2 minus x equals to, I see x here, I put square root of 2 minus x.
Oh, okay.
So this becomes square root of 2 minus x.
Okay.
Yes. But we know that square root of a is the same as a to the power of half, right? So now if you have square root of a, this is a to the power of half, and then a to the power of what? Of half again. This is a to the power of 1 over 4, which is the same as the fourth root of a.
Yeah, this one I understand.
Thank you. We sorted now, right?
Yes, ma'am.
Yes, ma'am.
Now let's find the domain. Let's find the domain, guys.
Is greater than 0.
What is greater than 0?
2 minus x.
Okay.
Yes?
The domain can be all the numbers up until 2. We cannot use numbers from 3 upwards because they'll give us a negative square root.
You guys are giving me the right answers, but the problem is that it will not work for you for the following examples, because here it's easy to see it. That's the problem. Like this one is one of the examples where by just saying that you are right, because I'll tell you later on.
So,
but can someone help me? What did we say? The domain of a composite function. Let's start there. Let's start there. You guys said understand. Let's start there.
Oh, it's the domain of G intersecting the domain of the expression of the composite function.
Thank you. What is the domain of G? What is G first? It's the domain of the inside function, right? Yes. So we know G of x is equal to, what is G of x? Square root of 2 minus x, right? What is the domain of G?
2 minus x greater than or equals to 0.
Greater or equals to 0. So we all know, isn't that we take 2 to the negatives to the other side, so this be greater than -2. So then this x such that we multiply by a -1 or we divide by a -1, x greater or equals to 2.
The sign changes. Doesn't the sign change?
Thank you. When you multiply or divide by -1, the sign changes. Less or equals to that. So that's the domain of what? The domain of the inner function. What do we need now?
The domain of f.
No, we say the domain of what? Not
we
the
need
domain
the domain of the composite function.
Yes, the expression. Let's say the expression, because we're looking for the domain of the we're looking for the domain of the composite function, but now we're looking at the domain of the expression. Let's call it the domain of E, F, G, something like that, so that we don't confuse it with the domain of F and G. Let's call it the domain of E. The expression E. So what is the domain of E? This is the expression of the composite function, isn't it?
Yes.
So what is the domain of that?
No.
It's
what you're saying,
the same as
the
same as the one of g of x.
Thank you. Are we all sorted?
Yes.
No, can you repeat that name?
It's because it's a root. You know, you can write this function like this. You can write it like this. And write it to the power of 2. So here you have a square root. So we know anything under the square root should be greater or equals to 0. So that's why it's x such that 2 minus x greater or equals to 0. So basically it's what we did from here. It's the same.
So the other square root. So the other square root does not affect the inner square root.
No, you can put it outside. Like this.
In terms of negative sign, does not affect it.
It's the same as, before that, give me the domain of y is equals to square root of x.
X greater than or equals to 0.
Give me the domain of y equals to 2 times square root of x.
Still.
Do you see that? So yes. Some constants don't affect unless you say 1 over. Hey, then you are like, then it affects. Do you see that?
Yes.
Yes. So now this will be the same as x less or equals to 2. Do you see that this is the same as this one? Guys?
Yes.
That's why you were able to get away with mathematical murder. Wrong answer, because these two are the same. And that's why you were able to get away with the correct answer. Because if you go back to your number line and draw the domain of G, which is this one here, G, right? It says, let's put 2. It says, what's this? Less than 2. It means all the values will be this side, isn't it? Now, let's draw the domain of the expression of the composite function. It's the same thing. It will be a 2 including 2. Do you see that? So the two graphs, the two lines, they cut each other from, what's this? So basically, it will be the domain of the composite function of f and g is basically x such that x is less or equals to 2. And can someone give me the interval notation? This is a set notation. Give me an interval notation, please.
Open bracket.
Yes.
Negative infinity to 2, including 2. Yes.
I'm happy. You're making me happy. Do you see why you were able to say, no, the answer, you just look at the expression and say, oh, the answer is this one. And you were right, because these two gave the same answer. So that's why it was easy for you. But with other examples, you see. So now we are moving. If we can prepare for the class next week, I'm telling you, we'll cover a lot. So they want us to find G composite F. So we know that f of x is equals to square root of x. Can someone give me an answer? And g of x is equals to 2 minus x. Can someone please give me an answer, guys? We need to hurry up. Been teaching for how many hours now? 4 hours. Come. I know you got this. What do I do? Or tell me what to do.
Ma'am, you want the expression there?
Yes, I want the composite function. What am I doing? They wanted to find this, and then after they find its domain, what do I do first? What are they saying in section?
F, the expression F is inside G of X, I think.
Good. So this means that f of x is inside g of x. Right? So we know that g of x is equals to 2 minus x. They say where I see x, put f of x. So g of f of x is equals to square root of where I see x, I put there. That is 2 minus of x. So this is square root of 2 minus f of x. Now, what is my f of x? F of x is that, so that is 2 minus square root of x. I like this one. So far, so good. It looks nice. Let's see if you can get the answer. I'll be so happy. Help me. What is the domain? We want the domain now. What is the domain, guys? How do I find the domain? Please help me. Guys, I need you to help me so that we finish and go to the next.
The values of the domain are between 0 and 2.
You're still making the same mistake as previously. What did we say? Let's go back to our next English statement.
Aren't you supposed to first find the domain of f at x?
Why f of x? Why not g of x? Why not g of x? What's special about f of x? Why find the domain of f of x?
Then
yes. Inside.
Yeah. Because
it's the one that's inside. Is the one that's inside.
Thank you. We want to find the domain of the inside function. So let's choose a different color. So our inside function is f of x. So that is f of x. So it means that it's square root of x. So the domain of I like G. Stands for good and God. Yeah. So f equals to, what is the domain here, people? And now I know now you are mastering it. So please help me. Fast.
X is greater than 0.
Someone else? Ed?
X is greater than or equals to 0.
Thank you. Do you understand why x is greater or equals to 0, isn't it?
No.
Because even if we put 0 here, it's going to give us answer. It won't say undefined. But if we had 1 over square root of x, then you can't say it will only be x greater than 0, because if you say equals to 0, put 0 here, it will be 1 over 0. So that's in undefined.
Oh, ma'am, I understand. I saw it.
Thank you.
Ma'am.
Yes.
Okay. What about the domain of 4 greater or equal to x?
What?
What if I said the domain of the expression is 4 greater than or equal to x?
4 greater than or equal to x.
Yeah, the domain of the expression.
4 equals to greater than x. How did you get it? So remember, we're going step by step.
Oh, yeah, that's why I didn't do step by step.
Remember, don't just look at it. We are not magicians. We need to do and let it make sense. If it doesn't make sense, no, something is wrong. Okay. Now the domain of E, we said we'll call it the domain of the expression of the composite function. Can someone help me? Oh, remember the interval. Now I'm not going to ask the interval notation. I'm sure we all know how to do the interval notation. So it will be 0 and positive infinity. That's the interval notation. The set notation is this one. Okay, so let's start with the set notation. X is an element of real numbers such that, please help me.
Okay, this is the domain of the composite function, right?
We said we shouldn't confuse the two. Is the domain of the expression. Let's call it the domain of the expression of the composite function.
Okay. So in this instance, so we're going to have 0 is less than or equals to x, and x is less than or equals to 2.
Guys, why are you going very far? I said let's start it simple. Can someone start simple for me?
I'm not very good when it comes to explaining, sorry.
No, it's fine. I understand. But remember, you can explain it like that. But for someone else might not understand it.
Ma'am, won't you start with x is greater or equals to 0?
Why only starting with x is greater or equals to 0?
Because that's the domain of f.
Yes, we are done with that one. It's this one. Then we go to we are here. We want the domain of the expression of that. If you're getting the answer, it's fine. But there are people who want to see where you started. Where did you start? Can someone remind me, what did we say if we are going to find the what's this? The domain of an expression that is the square root, what do we say? Guys?
Inside the square root, we must not have a negative number.
Yes. So what is, we said everything inside the square root should be what? Mathematically now, how do we write it? Isn't there, we said everything inside the square root should be greater or equals to 0. Right?
Yes, ma'am.
Even here, yes, guys, you will say everything under the square root. Everything under the square root should be what?
Greater 0.
Greater or equals to 0. That's where you start. Do you see that? Are we all okay, guys?
Yes, ma'am, I saw it.
Yes. Anyone else? That yes?
Yes, ma'am. We are sorted.
Thank you. Yes. So everything under the square root should be greater or equals to 0. So meaning that what is that everything under the square root? It's what? It's 2 minus square root of x. So let's solve it. X, let's take 2 to the other side. So negative x greater or equals to 0 minus 2. What do we do next? Please help. What do we do next?
Multiply by -1.
Yes. Multiply by -1 or divide by -1. So this becomes positive square root.
Less than or equal.
Thank you. Less or equals to 2. What do we do next?
We square both sides.
Thank you. Do you see why I'm saying start it simple? Someone said less or equals to 4. Do you see why I said start it simple? Because you gave me the answer and me, I wanted you to start here. Where you say everything under the square root should be less or equal to 0. Then you solve. And by the way, these steps are not in the textbook. That's what I've noticed. They say just is this answer, this is this answer. Therefore, that is that. I will show we understand up to this point.
Yes, ma'am.
Yes.
Thank you.
Yes, yes, yes.
You see that now you cannot get away with that other problem because now these two are no longer the same. Look at this one. The domain of the inside function. Look at that one. Okay, interval notation, less than that. So this will be negative infinity and 4 included. Yeah. So now the domain of f is x such that x is an element of, x is an element of real number such that x is greater or equal to 0. The domain of the expression of the composite function is x less or equal to 4. So how do I find the domain of the composite? Oh, sorry. How do I then find the domain of the composite function of f and g? Please give me the domain of that. What do I do next? I have my two domains, the domain of the inner function and the domain of the expression of the composite function. So how do I find the domain?
You say 0 is less or equals to x greater less or equals to 4. Hello?
Okay. Let's go back to our simple form as well. Where do we start?
Ma'am?
Yes.
Don't you check where they intersect?
So how do you check if where they intersect?
Number line.
Thank you. You draw the number line. Guys, there's a lot to cover. Like you need to put in your mind for the exam. There's a lot of work you need to cover. So if you don't understand the work and if you don't take your work to a simple term or a simple form, you might forget sometimes. So let's draw any domain. Let's start with this domain here, the DF one. It says 0 to where, left or right? Included. Do you see it's included, ne? So that's why it's a solid circle. Left to right?
Right.
Right. So I'll use orange. Okay. Now 4 is here. It's also included. Left or right?
Left.
Left. So what do you think our domain will be?
Square bracket 0 and 4. Square bracket.
Do you see that? So our set notation will just be remember the fish, the shark.
0 is less than or equals to x, and x is less than or equals to 4.
I will all sort it now.
Mm.
Yes, ma'am.
you see that you were not able to get away with it because now the two are different. So you had to draw a number line or think fast and then draw it.
Yes.
Thank you. Means we can move to the next one. See. So the other thing is that you'll notice the composition of F and G is not equals, it was not equals to the composition of G and F, according to the example that we did. Now let's look at C, one composite F of X. So we know that F of X is equals to square root of X. So we know that inside of F of X, we put what? We put F of X. So inside X, I mean, this is F of X. Where we see X in F of X, we put what? We put F of X. So this is like this. No longer X, you put F of X. Not X, you put F of X. So this will be square root of F of X. And this one will be square root of that. And this one will be fourth root of X. And this one you can also get away with it. But let's do it according to what's the first domain I have to find?
Inside function.
Which is?
F of X.
Thank you. The domain of F of X. We have seen that is X greater or equals to 0, right? And what other domain I have to find?
Expression.
Domain of an expression of the composite function, which is this one. Lucky for us is also X greater or equals to 0. So it's the same as that one. Remember the first one. So the domain of F composite. Oh, gee. F composite F is equals to X such that X is greater or equals to 0. This means that it's 0 included and positive. It's all sorted now, ne?
Yes.
Guys, thank you.
Yes, ma'am.
It means the homework. It means that you will do the homework right now. You sort everything. Okay. So now they want G composite G. Is someone asking a question? Ne? So it means G inside G of X. So where I see X, I put G of X. So this will be equals to where I see X, I put G of X. Where do I see X? 2 minus G of X. So what is G of X? I know G of X is this part. So it's 2 minus square root of 2 minus X. This is also another interesting one. So where do I start? Inside function. In this case, our inside function is G of X. So this is our domain. What is our inside function domain? We saw that this is 2 minus X greater or equals to 0. I don't want to solve it, so I'll go and copy it in the textbook. The answer was what? I forgot. Can someone help me? Remind me. So it was what? X less or equals to 2. We already sorted that one.
Yeah.
Now we go and check the domain of the expression of the composite function, which is this one. So we then, let's call it D of E, the expression of the composite function. Can someone help me? What did we say?
It's going to be 2 minus root 2. It's going to be 2 minus root 2. 2 minus X is greater than or equals to 0.
Why? Now explain it to a child. Why are you doing that? Because?
Negative of a square root is undefined.
Guys, if you're explaining to someone who doesn't know maths.
Because everything under the square root should be greater or equals to 0.
Thank you. Because everything under the square root should be greater or equals to 0. Only if it's not 1 over that square root of something. So something under the So everything, what is that everything? It's what you just mentioned, which is 2 minus square root of 2 minus x should be greater or equal to 0. So let's simplify that. I'll need help. I'll try to simplify it, but check if there are errors. Greater or equal to 0. No, this will be 2 minus 2. Are we all okay up to that point?
Yeah.
Thank you. Then I divide by or multiply by -1.
Less than.
Thank you. What do I do next?
Can I ask why didn't we just square both sides, because it was going to cancel the negative signs?
You know why? I wanted us to do where we divide. Because isn't that there was a time where we didn't have to square both sides?
Oh, okay.
Yes, I wanted us to always remember the sign changes, because if you don't do that, remember your exam is multiple choice. And I give answers if someone didn't change the sign. So you'll get all those answers. Where someone changed the sign, someone didn't change the sign, or someone used the wrong sign. That's how I make answers, isn't it? I have a problem and say, I know my student, one will not change the sign. Then I don't change the sign. Then I get an option of an answer. I'm like, I know one of my students will not divide by -1. Then I do that. And then you have all the answers. So whatever mistake or whatever you forget, you'll get an answer. Then the answer is wrong. So if you do it properly. Yes. Thanks. Now, this x, so square both sides, as you said, 2 minus x less or equals to 4. So this is x, then minus x less or equals to 2 minus 2. If I don't do it step by step, I'll forget. So this is x such that once this x is greater or equal to -2.
Oh, man, it was going to be the same.
Yes, I know it was going to be the same. I'm just saying that I wanted the division again. And I see here, I'm reminding you that if you multiply on -1, it's going to be the same. So now I have this part here. Yeah? I have this part here. What do we do? Please. Can you remember these domains, guys? I'm so tired. I won't remember it. So the domain of the expression, look at it. I want to go to the new page. Ne? The domain of the expression is this one. Do you see it?
Yeah.
And the domain of the function is this one over here. Just remember it. So we say the domain of the function. So we're looking at g was equals to x such that x is what is greater than x. Greater or equals to 2. Then the domain of the expression was such that x is less or equals to greater or equals to -2.
Less than or equals to -2. Okay. Oh yeah, greater. Oh, great. Yeah. Sorry. You're right. It was greater than or equals to -2.
Thank you. So x is greater or equals to -2. By looking at this, can someone give me an answer?
It's from negative.
So all the values between -2 and 2. So -2, yeah.
Do you know how we get this one?
Yes.
Yes, ma'am.
Draw a number line. Just as a reminder. I want it to be inside the head. So we draw the first, let's start with d of g. We know d of g is what? Is 2. Something is wrong with that, guys. Let's go back to our Oh, is that it? I think it's there. We said, oh, you say. Our D of G is this one. Can you please look at it properly, guys?
Oh, x is less than or equals to 2.
Yes. Thank you. So x is less or equals to 2. Once you get used to practicing, you'll see, oh, I made a mistake here. I made a mistake. So then this is 2, and 2 is included, right? So less than, it means I'm moving this way. Okay? Done with this one. Let's look at this one, but with a different color. Let's choose blue. So -2 is here. 2 is included, so meaning that 2 will be included. We want top of orange. But it says what? Greater than. So greater than is that. So this is -2. Greater than. So where do the two graphs touch? Between -2 and 2, both of them included. So meaning interval notation will be something like this.
Yes.
Thank you. Oh, are we all sorted now?
Yes.
Yes, ma'am.
Yes,
Yes,
ma'am.
I'm using my last power, but let's move. Okay, now we're done with that one. So it means it can help you with one of the questions. So already we've done a lot of questions you'll be able to solve. Practice. So a composite of 3 functions, right? I have something here. Okay. A composite of 3 functions. Let's say you have f of x equals to x squared. G of x equals to 1 over x. And h of x is equals to square root of x plus 2. Right? So now we're finding composite of 3 functions. So it means that it will be something like this. Please mute, guys. So do you see that? Do you see how it will be? The composite of 3 functions.
Yes, ma'am.
Yes. So many functions, you can even do 50 functions. But in this case, we're just going to end up to 3. Now, it means that inside of f, you put g of x, which has h of x inside. So the first step is to go and find h of g of x. That. So it means that it will be something like this. F, where there is g, where g is this one. So you put 1 over h of x. So 1 over h of x, this is the same as 1 over square root of x plus 2. You take this, you put it into the original function, this one. I mean, x squared, because it says wherever I see x, I put this expression. So this is 1 over square root of x plus 2. Wait, this is 1 squared over square root of x plus 2 squared. This is 1 over x plus 2. Are we finding?
Yes.
Yes, ma'am.
No, why you say f of x is 1 over h of x? I don't understand that.
Okay. Okay. Isn't that we're saying that h of x is inside g of x?
And 12x is inside h of x and f of x.
Yes. So let's start here. Let's start with this expression. We know g of x is equals to 1 over x. We know h of x is equals to square root of x plus 2. So g of h of x is equals to 1 over square root of x plus 2. Do you see that? Yes, no?
Yeah,
Then we
I
take
do.
this g of x, we put it inside f of x. So this is f of 1 over square root of x plus 2. This would then be equals to, we know our f is that, so we put 1 over square root of x plus 2 squared. This is equal to 1 squared over square root of x plus 2 squared. This is 1 over x plus 2. Sorted.
Yes, I'm sorted.
Thank you. It means we sorted with one of the problems. Now, recognizing a composite function. I think I gave you a problem, for example, g of x is equals to 1 over 1 plus x. And I'm telling you that g of x is equals to f composite g, meaning that f of g of x. So I want you to find the f of x, and I want you to find the g of x, such that when you do their composition, they give you g. So you go and look at the function cost. Can one give me the two functions?
G of x is 1 plus x, and then f of x is 1 over x.
1 over x. Let's see. So if you have f g of x is equals to g of x, so f x plus 1 plus x, then 1 over x plus 1. So this is that. So therefore you are right. Another expression. Who can give me another one? Yes.
F of x is equals to square root of x squared minus 4.
X squared minus 4.
Yeah.
And then g of x?
G at x is equals to square root of x.
So if you substitute these functions, will they give you 1 over 1 plus x if you do a composite of those two functions, f and g?
Yeah.
Hmm?
Repeat the question you say.
If I do the composite f composite g, will I get 1 over 1 plus x?
1 over 1 plus x.
Yes,
No.
you want functions? Yes. So it means that we can't use these ones. So let's try another one.
Okay.
Thank you.
If you
Another
use
one, guys. Yes.
1 plus x
1
over
plus x
over 1 plus x, right? Yeah, over 1 plus x.
That's 1. Yes.
And then you put it into the f of x, and it is it like that? And f of x it includes squared, which means this will be squared, and then no.
It won't work.
No.
You see that.
Yeah.
Can I give one last one so that we move to the last section?
Okay. F of x is equals to x to the power negative 1.
X to the power of negative 1.
Yes, and then g of x is equals to root x squared plus 4.
Root x squared plus 4. But still, if you find the composite function, you won't find the answer.
Yeah. It will be wrong.
Can I give the last one?
Yeah.
Yes.
Yes, ma'am.
So f of x, let me choose a different color. So f of x will be equal to 1 over x, 1 plus x squared. And then g of x will be equal to square root of x. So the composite of f and g will be something like this, which will become 1. Okay, f, I need to put the square root of x, which is equal to 1 over 1 plus square root of x. Do you see that? There is one. So it's So basically we have covered, I think, how many? 4 questions already today.
That's a lot.
That's a lot. One last thing is, remember someone talked about one-to-one function?
Yes.
But in the first discussion, someone talked about one-to-one function. What is a one-to-one function? That is page 219.
One-to-one function is when okay.
A one-to-one function is a function whereby its input by its x input value will give a unique output. So the values of x do not share the same output.
Good, 100%. But explain it to someone who doesn't know maths.
Oh, simply, ma'am, we can say to every x value there is a y value. There's one y value.
Thank you. Thank you very much. It means that, let's say you have your domain A and you have your range B, right? Now there's a function here, let's say maybe x squared plus something, something. We call it f of x equals to. So if x here, let's say these are your x's, this is what you get after substituting in this function. So you have 1, you have 2, you have 17, you have -4, you have 5. And then here you have 1, you have 3, you have 2, you have maybe 14, and you have -1. So if in your function you take the x value, you substitute into this f, and it gives you one value. This one goes here. Let's say the answer is that one. And then you take this one and you substitute into this function in the middle, and you get this value here. And you take this one, you substitute in there. You see, it only has one value. This one, you substitute it in there. And this one, you substitute it in the function, you get that value. You see, for every value in A, you only get one value in B. Do you see that?
Yes.
Yeah, okay, me, I didn't put it smart because this one's called. Some will say just like this, these arrows, one value, and one value. Yeah. So this is a one-to-one function. This one here. But if it happens, someone who was the discussion class 1 will tell me the exact function, which is not a one-to-one. If we have an x value, let's say 3 and 4, maybe -1 and 2. And then we have the y value 3, 2, 7, and 1. If we have that this value takes this value, and then this value as well takes this value, maybe this one takes its own, and that one takes its own. But 3 and -1, they get 2 if you substitute the function f of x. Then that is not a one-to-one function. Is that clear?
Yes.
Can someone give me an example of not a one-to-one function from first discussion class?
Quadratic function is not a one-to-one function.
Thank you. Quadratic function is not a one-to-one function. Because remember when we were solving that last question where it says you have M, and M is a reflection of C about the axis of symmetry, and we noticed that M and C had the same Y value. Therefore, quadratic function is not a one-to-one function. Are we all sorted?
Yes, ma'am.
Thank you.
Yes.
So by definition, there's a definition of f of x is equals to 1. They're saying that a one-to-one function is such that f of x1 is not equals to f of x1, right? So f of x2, if f of x1 is not equals to x2, whenever, I'm using f, whenever x1 is not equals to x2. So then that's a one-to-one function. But they are saying that you can also write equivalently and saying, if f of x1 is equals to x of x2, then it means that x1 should be equals to x2 for them to be a one-to-one function. If this is true, but this is not true, where x1 is not equals to x2, then it's not a one-to-one function, just like a quadratic function. Are we sorted up to that point?
Yes, ma'am.
Thank you. Now, if you have a graph like this, how do you know this is a one-to-one function or not? How do you know this graph is one-to-one or not?
We have a vertical line test or a vertical line test.
Or horizontal.
Thank you. Last time we talked about a vertical line test, right? Now we're talking about the horizontal line test. Don't confuse the two. If you take a ruler and draw any horizontal line, you must cut the graph how many times?
Once.
Once. Then it's a one-to-one function. Does it make sense?
Yes.
Thank you. So what they mean is, this is what they mean. Horizontal line test. This is one-to-one. Horizontal line test. You see it cuts two. This is not one-to-one. Do you see that?
Yes.
Yes, ma'am.
Thank
Yes,
you.
ma'am.
So now there's a statement. It says, it's actually on page 220. In fact, it can be proven that every increasing function and every decreasing function is a one-to-one function. A straight line is a one-to-one function. It's an increasing, either it's increasing or it's decreasing. Increasing function, one-to-one. Another increasing function, one-to-one. So that's the statement, what it's saying. Now, you'll go to deciding whether a function is one-to-one. G of x equals to x squared. Is this one-to-one or not?
No.
It's not.
How do you state that?
Can you?
So what you do in this case, you say this function is not a one-to-one because if you choose, for example, x is equals to 1, right? Let's say x1 is equal to 1 and x2 is equal to -1. You get 1. G of x2, you also get 1, isn't it? Therefore, G of x1 is equal to G of x2 when x1 and x2 are not equal. Do you see that?
Yeah.
Or you can say that if I choose, even if you say it in weight, you're saying that -1 and 1, they have the same answer for this function. That's why it's not one-to-one. You can say that if you want. And I'll not give you wrong.
So, ma'am, if you say there is 2 x variables.
Yes.
I would be wrong for y values, man.
No, if you're saying there are 2 x variables, that does what?
I mean, there are two. Not in. If it's a one-to-one function, we must have 1 x variable, I mean 1x, which will correspond to one y value. So
yes,
if like this, we have two, like sort of like one is negative and one is positive.
yes.
So
So
will
you
that
can
be wrong
say,
if I say?
no, you continue.
You can talk, man.
No,
I'm not
continue.
even making sense.
I wanted to hear what you wanted to say. You are making sense.
So I'll be wrong if I say it cannot is not a one-to-one function because we have two x intercepts.
There might be.
Okay.
So we can say g of x is not a one-to-one function because two x values or two input values are mapped to one output value.
Two equal values. There's a word you are missing there.
I'm saying two input values. Negative
two input
1
values
and
that are
1.
what?
It's two inputs are mapped to one output value.
Yes, but two inputs that are what?
Can be negative 1 and 1 or negative 2 and 2.
Two inputs with which are different.
Or two different inputs. Yeah, okay.
There you go. For example, let me make an example. You see when you go to the bathrooms where you have to pay in public toilets, right? Let's say you go to the bathroom for the first time, you put in 2 rand, right?
Yes.
And then you go out. Later on, you come back, you put in 2 rand. Am I going to say 2 people came in?
No.
You say 1 person, right?
Yes.
Came in, but came in twice. So it's very important to put the word 2 different inputs will give the same answer. Do you see that?
Yes,
so
yes, I do.
G of x is not a one-to-one function because you can get 2 inputs that are different and will map into one image or will give the same answer. Okay, so there's another way of showing a one-to-one function. You go through the examples, right? So they say show that f of x is equals to 3x plus 4 is a one-to-one function. Remember, if we can show that f of x of 1 is equals to f of x of 2, for x1 is equals to x2, then it's a one-to-one function. It means you are saying that x1 and x2, they are both equals to 2. So if this is true for values for the same, okay, if this is true for the case where x1 and x2 are the same, then this is a one-to-one function. But if this f of x plus 1 is equals to f of x plus 2 for x plus 1, which is not equals to x plus 2, do you see that these are 2 different values, yet they give the same answer? Then that is not a one-to-one function. So that's another way of showing. So meaning that you can go and say f of x1 equals to 3x1 plus 4, and f of x2, which is equal to 3x2 plus 4. And then you equate them. So you say f of x1 equals to f of x2, and then you have 3x1 plus 4, which is 3x2 plus 4, minus 4 both sides. You're left with 3x1, which is 3x2 over 3 over 3. Therefore, you get that x is equals to 1. X is equals to x2, sorry. So meaning that f of x2 is equal, f of x1 is equals to f of x2 for x is equals to 2. Then you have shown that this is a one-to-one function. That's another way of showing that it's a one-to-one function. Are we all okay?
Yes, ma'am.
Okay. Is there a question?
The question is that, ma'am, please, like, can you make, like, I'm always confused when I encounter a question where they ask a domain of an inverse of a function.
That's where I'm coming. So I only have 10 minutes before lecturing. So the inverse undoes what okay. So the inverse function, let me relax. 10 minutes is a lot. The inverse function undoes what the normal function does. For example, if you have x, right, and you substitute it in the function f, you get f of x, right? If you take this f of x and substitute it into an inverse of f of x, you go back to x. So if f of x, the domain, was A, the range was B, then the inverse represented like this. The domain will be B. The range will be A. Do you see that?
Yes.
So they just interchange. The domain for f of x becomes the range for the inverse.
And
so
then
you
they'll do this.
Yes.
No, we can talk, ma'am. And
Can
then
I finish here so that when load shedding kicks in, if I don't get your answer, I can answer it via email.
Yes.
So you read this is the last part of chapter 2 actually. So now there is inverse function property. So they are saying that to verify, like for example, if you want to verify that the two functions are inverses, let's say you have f of x is equals to x to the power of 3 and f of x, the inverse of f of x is 1. What am I saying? Is x to the power of 1 over 3, right?
Yes.
Then you want to show that these two functions are inverses. It means that you're going to look at the inverse function property. So the inverse function property will say that f of inverse of x should give you x. Right?
Yes,
and f inverse of f of x would also give you x. So if you get these two, then it means this function and this function are inverses of each other. So let's see if these two are inverses of each other. Let's start with f opposite the inverse of the function. So with f, we put this one, so it's x 1 over 3. Where we see x, we put 1 over 3. So this would then be x 1 over 3 to the power of 3. So we know that 1 over 3 times 3 is equals to 1. So this is x. Let's go to the other part. So this is inverse composite f of x. So we know inverse over f of x is x to the power of 3. And then we know our inverse is x to the power of 1 over 2. So that's x to the power of 3. 1 over 3. Which one is an outside function? Oh, inverse. So 1 over 3. So this gives x. Therefore, f and x, f and f inverse are inverses of each other. So this is how you verify that this function is an inverse of the following function.
Oh. So does it apply to logarithm if you have an inverse of a logarithm function?
Remind me when we are doing what's this? Logarithm function.
Yeah.
Remind me when we are doing it. So we do
cover it in the next live discussion class live.
Yes. Remind me. Isn't that we are not there yet? Remind me once we are there, we'll do it. And see.
Okay, man.
Thank you. So now, the last part. I feel I'm tired. Last one is find an ease of function. And then we close.
Oh, yes, man. Asipushile fun.
We're not repeating what we did today. Next week, we need to be working smart, guys. The first step, Nick, you write your function as y equals to something, f of x. Please mute. Please mute. Do you see that? The second one, you will solve for x in terms of y. The third step, you interchange. One can ask me, ma'am, can't I interchange first, then solve? You can do that. You can say step 1, step 3, then step 2. Or you can say step 1, step 2, then step 3. It doesn't matter. Are we all okay there?
Yes, ma'am.
I'm left with 4 minutes. Let's see if I can find the inverse. If I'm shut, then it means that load shedding kicked in. So f of x is equals to 2x plus 3, yes?
Please don't forget to tell us about the homework, because I didn't get that at the beginning.
I will type it in the chat with my phone.
Okay, no problem.
This chat. Thank you. And I'm sure my UNISA, no, I'll type it in the chat. My UNISA might write as well. So remember, we said we write this as y. So that's our first step. So y is equals to 2x plus 3 over x minus 1. So Mina, I will not interchange first. Let me just solve for x with respect to y. So multiply this both sides by x minus 1. So we have x minus 1 y equals to x minus 1 2x. What you do in the right, you have to do on the left side as well. So this x minus 1 cancels that one. So we have x minus y, or sorry, x minus 1 y equals to 2x plus 3. So then we have yx minus y equals to 2x plus 3. So, okay, let me take this one to the other side. So it's 2x plus 3 equals to yx minus 3. I just want to put it like this. 2x plus 3. Take out y. What am I doing? What am I saying now? I'm tired.
Are you solving for?
You're right. We factor out y.
Yeah,
We'll factor out y.
Yeah.
Okay, then why did I multiply it here? I'm so tired. 5 hours is a lot, guys. Okay, let me see if I can do it. I'm on my last energy. 2x plus 3 over x minus 1. So y is equal to 2x plus 3 over x minus 1. That's the first step. So I want to write the x in terms of y. So it means that I'll say x minus y. I mean, x minus 1, y equals to 2x plus 3. Then I'll say xy minus y is equals to 2x plus 3. So I want to write x with respect to y. So I say 2x plus 3 equals to xy minus y. Right? Then Then 2x equals to xy minus y minus 3. My brain, please don't fail me. Minus xy equals to minus 3 minus 3. I don't know what I'm saying, but I think it's correct. So I factor out x, right? X, 2, minus y equals to minus 3 minus y. Then x is equals to minus 3 minus y minus 3 over 2 minus y. Am I right?
No,
Gosh.
it doesn't look right.
It does. So then if I take out the negative outside, so this is y plus 3 over
I think we should call it a day, man, because I'm confused.
Yeah, I think her network cut off.